Hi everyone, my name is Josh, and this is Unique Amps. Welcome to Unique Amps, Episode 2. At the end of my first video, I included video from me playing around with a Tesla coil, capturing some cool arcs for my intro, and at some point halfway through the overhead light turns off. Well, that wasn't on purpose, that was accidental, likely due to transients from the high voltage. So I tore apart my LED magnifier and found this little LED driver board inside. And likely the high voltage transients killed the chip in the middle that you see there. So there's a couple options. One is try to figure out what that chip is and replace it or repair whatever's broken on the board, or tear it apart and see what else could be done. I do have these 39 ohm 5 watt resistors just laying around, so I thought, well, maybe I could use these for something. So I fired up my soldering iron. I got my trusty meter and got to work. Using my X-Tech DMM. So I had already checked the polarity of the LEDs previously and mark the connector with a plus. Brown wire is positive. But I'm just verifying the voltage on the power supply. It's at 24 volts, little switcher. And I wanted to verify it for the sake of the video. So there it is, 24.5 volts. And then just briefly connecting the power supply to the LEDs provides a really bright flash, because the current's not limited at all. Don't want to prolong that connection and burn out the LEDs pretty quickly. So my idea was to connect one of these 39 ohm 5 watt resistors in series, limit the current, and to start out with, wanted to do some testing, so wanted to see how much current actually would be flowing through the LEDs. So I set the meter up to measure current, 10 amp. And there it is, 250 milliamps. It's actually relatively dim, dimmer than I remembered it being on the current driver. So what I'm doing is just connecting another 39 ohm resistor in parallel, essentially doubling the current. And so there you see it's about 470 milliamps. And so I'm just letting it run that way and checking the resistors for temperature, make sure they don't get too hot, nothing's burning up. So I'd already stripped the wires previously, and now I'm going to tin the wires, essentially just make sure that they're twisted together, not frayed, and solder, add solder to get them ready to solder to the resistors. And it's taken a while for this old soldering iron to get warm. So, sip of the old Voodoo Ranger. See if it's hot yet. So I might do a soldering tutorial at some point. We'll see. But basically just heating up the wire and making sure that the power supply is unplugged before I do that. Heating up the wire, and the idea is to to apply the heat to the wire and then apply the solder to the wire, not really to the iron. It's technique, takes some practice. After a couple thousand solder joints you get pretty good at it. And so over the years too, I've developed essentially just grab the wires between my fingers and hold them in place while I tin the ends. So now I'm figuring out kind of how I best want to route everything, and thinking how I want to mount both resistors connected together. So I thought at first that, well, maybe I just cable tie them together, or I do have some bus wire. I figured let's try wiring them together. Just wrap a wire around the bodies of the resistor and then solder them together. So I trimmed the very ends of the standoff leads off. Didn't really need them. They're just extra room. They were designed to go into the through hole PC board and then essentially stand up off the board so that the air would circulate all around the resistors. And so again, I'm going through and tinning the leads, straightening the wire, again tinning the bus wire, and then soldering the bus wire to one of the terminals. And then once that's solidified, then soldering to the other terminal. And the trick here is to provide enough heat to solder to the second terminal without melting the first solder joint and letting the wire fall off. So it's a little bit of a trick. Applying the heat, applying the solder, and then removing the heat quickly, and keeping the second solder joint liquid before or without liquefying the second solder joint, the first solder joint. So it looks pretty good. Clip the bus wire off, do the other side. Same technique. Solder the end of the bus wire to one terminal first, and as you see, I actually tinned the bus wire a little more than the first side, so that it would solder more easily to the second terminal. Then I went back and just made sure the first joint was adequate too. Okay, trim it off. And I decided bus wire connecting the terminals is probably robust enough to keep the resistors held together, so I didn't really need the middle bus wire. Then again, just kind of dry fitting everything together, figuring out how I want to route it all. Then you need to connect two of the wires to connect essentially the grounds together from the power supply to the LEDs. And so I'll just solder the wires together and splice, but then use a piece of heat shrink tubing. So I was just making sure there was heat shrink tubing, and slide the heat shrink over one wire first away from the solder joint so that the active soldering it doesn't shrink it down prematurely. Then my technique is to hold the wires together, and a better technique probably would be to twist them together or to hold them together using some sort of a vice grip or something like that. But I found my technique to be strong enough and robust. So there, just pulling, demonstrating that just the overlapping wires soldered together is pretty strong. It's up close.
What are you doing?
Come down and see. So then slide the heat shrink over the joint, make sure it's kind of centered, and then I use this torch. You can use a heat gun too. Torch is a little more dangerous. You gotta be careful about not starting it on fire. But again, practice. I do recommend getting one of these torches. Probably get them, I think, on Amazon. They're really indispensable for this kind of work. So then soldering the positive. I think that is coming through the switch. There's an on-off switch on the top of this. So simply just soldering positive to one side of the resistors, and then the positive of the LEDs to the other side of the resistors. If they're connected backwards, they're not going to light. They won't work. So pretty much just same as before, just solder the wires on. Try to get everything situated. You get the cover and see how the cover fits. And again, route the wires and to tidy up the rat's nest. So before buttoning it up, make sure it works. Yep, seems to work okay. Power switch works. Alright, time to button it up. So I decided I had some glue sticks, hot glue, and so I don't expect the resistors to get hot enough under normal operation to remelt the glue. So use the torch again to melt the glue stick. Just get some on the resistors. And then same thing for the plastic housing. So I preheat a little spot and then get a little hot glue in there too. And then heat both sides again until the glue is liquid, and then stick it in there. So because these resistors will get a little warm during normal operation, I plan to pull this apart and check them after a couple weeks just to verify that they haven't fallen off. Yeah, nice torch. And it's not going anywhere. So for tidying up wires, cable ties work excellent. Get the cover back on. As I was getting the screws back in, I noticed the wires coming out the back weren't coming out exactly as I wanted them to, so I pulled the cover off again. And then I noticed that I didn't install the strain relief on the inside. So I got that in there and then moved the wires around so everything was out of the way of any of the partitions, or there's nothing that was going to get pinched. Everything was tight and routed well and fit well, so I get the cover back on and screwed down. So I think I was done with the soldering iron, so last thing before turning it off was to coat the tip again with solder, fresh solder, shut it off. And then get the cover over the LEDs back on as well. Yep. Test it out. Yeah, it works. So it looks like this LED magnifier will live on. Job well done. In the next video, I'll finally get to some amplifier stuff. So, thanks for watching and see you next time. Hi everyone. Nice. Hi everyone. Try again.
Are you reading or not?
What are you guys doing? Not supposed to be in there. Get out. Come on. Out. 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 Come on. Out. Come on. It's not that awesome. You too. Go. Come on. Garbage.